Hello and welcome to Cloud OnAir, our webinar series from Google. Today we have a series of 4 talks ranging from security and IT management tools. Please feel free to leave some questions during our talks in the platform as we have staff to answer them. In addition, we'll have some Q&A at the end of each of these talks. So hello, my name is Dan Paik. I'm a product manager on the Google Cloud Platform. I work on Container Engine and Kubernetes. And today I'll be talking about running your first containerized application with Kubernetes. We'll go over containers and why we at Google use them. Hint, it's really because of the right level of abstraction to optimize our infrastructure for our applications. We'll go over Kubernetes and what it takes to actually manage and container and orchestrate your containers in a production environment. We'll talk about Container Engine, which is our managed Kubernetes service on the Google Cloud Platform. And we'll discuss some quick Kubernetes concepts and Kubernetes components before we jump into a quick demo showing you all of the stuff in action. So let's start with what containers are and why we use them so much here at Google. Some of you may remember back in the day when we used to deploy applications like this, right? People used to deploy applications on shared machines. You had multiple teams writing applications with multiple applications all on one machine. They shared a common set of libraries and kernels as their dependencies, right? But imagine if you have to upgrade your libraries, upgrade your kernel. How do you do so without breaking the other applications that are running? This was very difficult to manage, and it really caused a lot of problems. This was very painful. So people moved to this. They moved to VMs and bare metal, where you had great isolation. You had each application running with its own set of dependencies. But look at this diagram here. There's a bit of waste, right? We see a lot of replicated kernels here, right? We see the yellow box in 4 different places. And imagine if you have thousands of applications running on thousands of machines like this, right? Then what do you do when you need to upgrade the kernel because there's a security patch that came out? Well, it becomes very difficult to manage. And this is highly inefficient. So it really brings us to containers and why we think containers are the right level of abstraction. You have your applications, they stay isolated from each other. So one application isn't going to cause another application to go down. Yet they're all on the same machine, and they all share one kernel. So if you need to upgrade the kernel, you can do so fairly easily, and you can upgrade libraries independent for each application. So this is great. And Google's a great place to run your containers. I mean, we contributed some of the core container technology code to Linux over 15 years ago. In fact, at Google, we've been using containers to manage our applications for over 12 years. And the Google Cloud Platform has multiple ways where you can run containers. You can run them in Compute Engine on managed instance groups. You can run Kubernetes. So you can run your containers through Kubernetes on Container Engine, which we'll talk about in much more detail today. And you can even run them on App Engine Flex. But no matter how you run your containers, on Google, they all benefit from our world-leading fiber network. And Google already has numerous data centers around the world. The ones that are in blue are those that are scheduled to come online later this year. So we are global. And one of the things that I personally love about working for the Google Cloud Platform is really how open we are. Here's a quote that one of our VPs said at the last GCP Next, where he said, "We're going to be the open cloud. We're going to give you the freedom to join and to leave. I'll take my chances." So this commitment to openness and freedom means you have more options, and we'll stay highly motivated to continue to provide the best service and experience for you without lock-in. And that's really what brings us to Kubernetes. So hopefully by now you understand that containers are great. They're the right level of abstraction. They're really good to use. And believe it or not, running a container is actually very easy to do. The problem is when you need to run containers in a large environment, in a productionized environment, well, then you need tools. You need tools that are going to help you scale, deploy code, optimize your resources. These are all the things that you need to actually run containers in a realistic production environment, and this is where Kubernetes comes in. Right? Kubernetes is an open source, container-focused workload level abstraction, and it abstracts things like your network, storage, compute resources. It really enables you to run your containers in multiple environments. You can run them in the Google Cloud, you can run them in other public clouds, you can run them in your on-prem data center, and you can even mix and match these things. You can run multi-cloud, or you can run hybrid environments where you have some of your clusters running on-prem and some of your clusters running in cloud. And Kubernetes is highly resource optimized and it's microservice friendly. And we'll talk about that in detail right now. So if we look at resource optimization, this is the old way that we used to manage resources. Right? we have 3 different services here. The blue boxes are each individual machines, and you have a service running per machine. So anytime you need to scale a service, you just keep adding more of that service to the machine that it's running on. But let's look at service C. Service C is pretty full, and let's say service C starts to get more and more traffic, so we need to scale that. Well, the only way to really scale that now is we have to add another machine for service C. But look at all that empty space in these boxes where service A and B are running. Wouldn't it be great if we can combine all these services together into a common set of machines? And that's really what Kubernetes enables. You get this more efficient utilization because now we have services A, B, and C all running on a common set of hardware VMs. And you have isolation so that these different services can independently run without negatively affecting the other services that it's running on based on traffic patterns and based on even if a service goes down, it's still protected. And you can imagine that if you have more and more services, this becomes more and more important. You know, if we had 3 services in this example, now we have 5, and imagine if you have thousands and thousands of services. This becomes very important to make sure that you can efficiently run and optimize your existing infrastructure. And much like containers on a container ship, with Kubernetes, you can mix all of these different workloads into one platform here. So it's clear that Kubernetes helps you efficiently manage these resources, and you know, right here, it may even help save a data center, right? Because if we looked at that first diagram, as we start adding more and more boxes, you know, adding a box could be somewhat trivial, but do that thousands and thousands of times, and at some point, you end up running out of space in your data center, so you end up having to build a new data center. So Kubernetes can help you even save a data center. So next, let's talk about Container Engine. So Container Engine is built on Kubernetes. It's built on open source Kubernetes, and it's pure upstream open source Kubernetes. So any Kubernetes cluster that you have, if you're using open source Kubernetes on-premise and other clouds, portability is key because we don't take that version of Kubernetes and make any changes to it. So it's highly portable for any open source version of Kubernetes that you're using because we run the same version in Container Engine. But the good news with Container Engine is you don't have to worry about the complexities of managing your own cluster. We keep your cluster running for you at all times. Kubernetes has a concept of a master as well as multiple nodes, and we manage the master for you. If you end up having more and more nodes, then we'll upgrade the master to a different machine. And all of this is seamless that we do in Container Engine. And more importantly, you also have Google as your SRE. So SRE is Site Reliability Engineers. We manage your cluster for you. We keep it up and running so that you don't end up getting paged in the middle of the night because of something wrong. If one of your nodes go down, we'll bring it back up again. So we'll keep your cluster up and running. If your cluster gets unhealthy for any reason, like we start detecting slowdowns, we start detecting problems, we'll proactively go in there and start fixing things. We have liveness checks, we have liveness probes, you know, and we also have a lot of high availability, you know, through a lot of the replication strategies that we have to make sure that your cluster stays up and running at all times. And also important to scale. We're able to auto-scale your clusters for you so that when you have sudden spikes in traffic, you don't have to get up and start replicating yourself. We'll automatically detect these spikes in traffic, and we'll scale down. And in Container Engine, scaling doesn't just mean scaling up. We also scale down when you don't need the additional infrastructure that you have. So we'll scale down to 1 machine or 0 machines if you really want to, and we'll scale up to thousands and thousands. And because you're in public cloud on the Google Cloud, there's really no limit in terms of like the number of machines that we can scale up to. And really by running Container Engine, you get all the benefits of Google Cloud, right? Google Cloud has industry-leading boot up times, competitive pricing, global load balancers, great storage options. You know, we have great products such as Cloud Spanner, Cloud Bigtable, Cloud ML Engine, things like that, that you all get the benefit of by running a Container Engine because it's also part of Google Cloud. And if you remember last year, there was a great big launch, Pokemon Go. Niantic was on Google Container Engine. And you know, if you look at this graph down here, the orange line on the bottom, that was their original launch target. The estimated worst case that they came up with was 5x. It was the red line that's right above that. But the green line is really what the actual traffic was. And you can see that was 50x what they estimated. So this type of scalability, this type of growth, this type of planetary scale was really possible by going with a solution in Google Cloud using Container Engine. So, you know, so we're really able to scale to this type of traffic and load that's really at a planetary scale. So before I jump into a demo, let me tell you about some of the core concepts of Kubernetes. Because Kubernetes is a workload level abstraction, works across public cloud, also works across on-prem, there are a few new terms that we need to go over. The first is on containers. So we're all pretty familiar with containers by this point. Hopefully, some of the earlier slides that I showed you give you a quick introduction to what containers are, why they're a great level of abstraction, and the use of containers. But Kubernetes uses a concept called pods. Now, a pod consists of one or more containers, and really what we do here is these containers that are in a pod are usually tightly coupled. It could be just one container, and that happens in many situations as well. But sometimes, people want to put a container in, they want to couple it with, say, another container that has policy that it's going to enforce, or it may have some type of logging that it wants to enforce. And you want to couple these containers together and scale these and schedule these together as a pod. So the core concept of Kubernetes is we're going to be scaling pods, and we're going to be working with pods as our base level. And then we have nodes. So a Kubernetes node is really nothing more than a machine. It could be a VM, it could be bare metal, but nodes are where our pods are really going to run. So the next concept is around deployments. So a deployment is really just a declarative statement where we create a deployment and we state the desired number of pods that we want running at all times. And Kubernetes will make sure, and we'll see this in a quick example, it'll make sure that it keeps that deployment up to date with what we desire. The deployment object is really what we interact with on a regular basis for scaling and things like that. So let's say we have a deployment here. We say we want two of pod A running at all times, and we want one of pod B. In this example, we have a 3-node cluster, so we have 3 different boxes here. We have pod A running in 2 of the nodes, and we have pod B running in 1. So our desired state of 2 pods of A and 1 pod of B, and our observed state is the same. There's really nothing for Kubernetes to do here. We're very happy. Things are running very smoothly. But what happens if one of our nodes crash? So imagine if our node here on the left crashes. Well, now we have a problem, right? Because now our observed and desired is different. We only have 1 of pod A running, and we have 0 of pod B running, yet our desired is we want 2 of pod A, and we want 1 of pod B. And as you can see, there's some empty space over there in another node that we have sitting there. So that's what Kubernetes does. It's going to automatically detect, usually within a few seconds, that the desired and observed state is off. So let's fix this. And it's going to then fire up another pod in that other node, and it's going to fire up another pod for pod B as well. So now we're back into this happy state where our desired and observed state is in equilibrium again. So this is great. This is how Kubernetes keeps your systems up and running at all times, right? And this is very fast. This all happens automatically. So you're not getting paged, we're not getting paged. Kubernetes just handles this. And really the last concept before we jump into the demo is a service, right? So service, so one of the things that you can imagine here is, imagine we want to tie a load balancer, and we want to tie an IP address to access our actual pods, right? Well, in the past, you would have tied a load balancer to one of these nodes, right? The problem is these nodes can change, right? The pods that are actually running in the nodes, there's no real guarantee that a pod will run specifically on a node. So what we want to do here is we want to set up a service, which is a group of identical pods, and we're going to tie a load balancer to the service so that if pod A were to move from one node to another, we're still calling the right pods. So this is an important concept because it's a different way of thinking where you're thinking from a pod-centric service view as opposed to a node and machine view. So let me jump into the demo, and we'll do that real quick. So this is Container Engine. This is what the interface looks like. Let's say I wanted to create a new cluster. I'll go in here to create cluster. And this is very easy to do. You just name your cluster. You can set up a description. You choose a zone. Earlier we saw in that diagram all the different global areas that we're available in. So you can choose any of these zones. For cluster version, we have the default version, which is our latest stable version. And we also have things like the latest versions that are available, like 1.7.5. And open source Kubernetes releases a new version usually every 3 months. And so at this point, we're in the 1.7 series, and 1.8 will launch at the end of this month. You can also choose the machine type that you want here, how many vCPUs you want, the type of memory you want, choose the image. You can choose how many nodes you want, whether it's a 3-node cluster or more. Some of the things that we talked about earlier around auto-scaling and things like that, we can also configure as well. And we also have logging and that kind of stuff. So these are all the different options that we have. It's actually very quick and easy to create a new cluster. And usually within a few minutes, you'll have a cluster up and running. So I created a demo cluster already. It's already been created there, so it's set up for us already. I'm going to run this test running using a quick Node.js application. So here I created a little directory here. I have a file here called server.js. This is really just a Node.js file here. It's running. It's going to require HTTP. We're going to hit this server. It's going to listen to port 8080, as you can see, and it's really just going to respond with a hello world. So this is not containerized yet. It's not running in Kubernetes. There's very little that this is actually doing other than running a Node.js application. So let me test this by typing in node space server.js. So now it's actually running. So I want to actually hit this machine in port 8080. I'm using Google Cloud Shell here. This is a very sort of quick and convenient way that you can access your cluster. You can also set up your local machine, whether you're on a Mac or Windows or a Linux box, with the G Cloud tools to access this just as easily. So once we're here, we have this tool here called Web Preview. I'm going to preview what I'm doing here in port 8080, and what we do see is we see hello world, which is what was expected, right? So, and back here I say, hey, I got this request coming in, so this is all working great, and this is exactly what we want to see. So I've tested to make sure that my server.js file itself is a valid file. It doesn't have any bugs in it, and I don't have any syntax errors or anything like that. The next thing that I'm going to do here is I actually want to now containerize this, right? So I want to create this as a container. I'm going to use Docker to do this. And the first thing is we have a Docker file sitting here. So if we examine the Docker file, it has the version of Node.js that I want to use. I'm going to expose port 8080, and I'm actually running this file here, which is the server.js file. And so to run this as a Docker file, I have a few commands here that I'm going to run to actually create the Docker image. And I'll go through this in a second here as well. So the 3 commands that I ran was, first I decided to do a quick build. So I built this server.js file as a Docker container. And I pushed this over to GCR, which is the Google Container Registry. So it's the registry that we use at Google, but you can push this to any container registry that you have access to, and it will push the Docker image over to that registry. That's what this command here did. The next command is, well, now I'm using Docker itself to run this on port 8080. I created this as hello tutorial, and I'm running the image that's sitting there in the container registry that I just created. And kind of the third thing I did was I just did a curl of localhost 8080. And the result of this curl was, as we expected, we see hello world on the screen. So now the difference that I've done here from the first demo is I'm actually running this as a Docker container image, as opposed to just running this command line through Node. And if you know Docker, you can do some standard Docker commands like see which Docker processes are running and things like that. So what we've done here is we've taken a Node.js application. We tested it first just using Node in the command line. Next, I created a Docker container for this, and I tested this running as a Docker container image. So that's great. So the next step now is I actually want to run this and have this container managed by Kubernetes. So that's what I'll do next. I'll run a series of commands here, and I'll talk through this as the commands run. So first, I'm going to create a deployment. And then I'm going to actually expose this as a service. So what we talked about earlier, where I'm going to tie a load balancer in front of it. So here are the different things that I did. Let's go back to the top here. So this kubecontrol run hello node of this actual image. So now I specify the same image that I had just created, and I'm running this as a deployment called hello node. So if we look to see what deployments are running, you see the hello node deployment there. It's the desired state that we talked about earlier. I desire one pod. We have one up to date. There's one running currently, one available. It's been running for 21 seconds. So running with Kubernetes, now I have that container actually up and running, which is great. I can also do a get pods to say, give me the information about the pods, the actual pods that are running. So here I say hello node, and I see this long string at the end. That's the identifier of the specific pod that's running. Just for reference here, you'll see this other Redis stuff. That's another deployment that I've also been fiddling around with, and I've been playing around with that as well. But the one that we're looking at for this demo is this Hello Node pod that's running here. So we see the cool pod running there. The next thing I did here was I exposed this deployment of Hello Node to a load balancer so that I can actually hit this deployment from an outside public IP. And then the next statement here is I want to get the services for Hello Node. So earlier we talked about setting up a service for pods. I set up a service here, and I wanted to expose this as a load balancer, as an IP address. So what we see here is we see that an external IP address was created, and here's some information on that. If I go back up here into our UI, into Discovery Load Balancing, I'll see that for this Hello Node, there's an endpoint that was created. And if I click that, it should take me out to this URL, which then says Hello World. So now this is a URL. It's been exposed to the outside world. Anyone can hit this from anywhere on the internet now. And now it's actually running my container. So the last thing I wanted to take a look at here is, so this is running. Everything's great here. If I run like kubectl get pods, I have one pod running. But what if I want to scale this, right? So the next strength of Kubernetes is let's actually scale this deployment because we have a lot more traffic coming in, right? So to do that is very easy. You can automatically scale these things, but I'm going to show you how to manually scale them because we don't have a lot of traffic coming into this right now. So if I wanted to manually scale this, all I really do is I just scale the deployment in Hello Node and say how many replicas I want. So I said, hey, I want 4 replicas. Now if I get pods, we see that instead of the 1, I now have all 4 of these running. So this is really a great and easy way using Kubernetes to now manage our containers. So if we take a step back to see what we did, we have our server.js application, runs great in Node. We then containerize it, runs great using Docker containers. And then now with Kubernetes, we're actually managing it to keep it up and running. We have 4 replicas of this running. And like we showed in some of the earlier slides, if any of these Hello Node pods were to go down, or if any of those nodes go down, Kubernetes will automatically bring it back up to the state over and over again, right? So let me go back to these slides now. Okay. So if you thought that was interesting and you want to play around with some of these Kubernetes concepts and Container Engine on your own, please feel free to do so. Here's a couple of links and slides. The tutorial that I just ran, the link is right there for the Hello World tutorial. There's some other information around like the code itself and the configuration and some things that you can do to further your knowledge on Kubernetes as well as get started. And really, thanks for hanging out here with us. In a few seconds, I'll be back to answer any other questions that we have. But feel free to hang out a little bit. But yeah, I'll be back in a minute. Thank you. Okay, so here's a couple of questions that I got from the audience. Thank you for entering these in. The first is, what happens if I fill up my nodes with containers? Will Kubernetes scale automatically for me? So this is actually a pretty good question. It's a complex question. There are 2 things that are working at play here. So first off, if you have additional scale, then Kubernetes itself needs to add more pods. So the demo, I added 4 replicas of those pods, and the pods will just run in a certain number of nodes that are running. So the first step is Kubernetes has a feature called horizontal pod auto-scaling, where if you enable that, then we'll just start adding more and more pods, right? So that's number 1. But the important question here is, well, what happens if I no longer have space in my nodes, right? Then what happens is those pods will go into the state called pod pending, where it's like, hey, I'm trying to add more replicas and get more pods running, but I have no space in my nodes. So this is where Container Engine comes in, where if you're running on Container Engine, you can set up node auto-scaling so that it will automatically detect that, hey, I need to create and get more nodes. So it'll go out and get more machines for you so that you can then add those pods into those nodes. And node autoscaling works within Container Engine, where you set up a minimum number of pods, a maximum number of pods if you want to do so like that, and we'll automatically scale up to that maximum. And you only pay for what actually gets used. And like I mentioned earlier in the slide, later if the traffic then goes down, we'll scale down those nodes and we'll drain the nodes and move your pods to other nodes as traffic decreases over time. So that's all managed automatically for you. So it's two concepts here. There's Kubernetes horizontal pod autoscaling, as well as Container Engine node autoscaling that you need to take a look at here. Second question is like, if I want isolation of my containers, why would I couple them together in a pod? Can you elaborate on when I should use multiple containers in a pod compared to a new pod for each container? So that's a good question. If you want isolation of your containers, then you actually should use them in different pods, right? The times where so you wouldn't couple containers together that are like different applications and things like that, right? Where you couple them together is if you have a container that you want to always scale at the same pace and same time and running in the same node as another container. So some of the examples are, if there's policy that you want to enforce in your other containers, then you may group those together so that the main container that you have running will always implement the policy that you have there. Some of the other examples I think I gave earlier was around like some type of like logging or monitoring, where I want to keep, like you may have an Nginx container running as well as a logging container for that Nginx, and you want them to always work together, so that anytime you scale the Nginx, you also want to scale the corresponding logging along with it. So that's the times where you use that. But if you really want isolation, then you're right in that you would want to have one container per pod and just run it that way. The third question is, how is a bill calculated with Container Engine? Do I pay for things like disk ops as with App Engine, or is it billed as a resource, machine disk level? So really the way that the bill is calculated with Container Engine is we pass through the cost of the underlying resources. So a lot of what we run in Container Engine is, when you run a node, you're running a compute engine resource. So we pass that cost on to you. If you're running disk, then we pass that disk cost to you as well. Networking, we pass on those costs to you. So it's really, you pay for what you use of the underlying GCP platform as well. And then with Container Engine, we have a free tier where we don't charge anything in addition for management, but there's a certain level of a certain number of nodes where we start charging you flat, sort of fixed fees per hour for Container Engine, where you have a certain cluster that's of size. Okay, so the fourth question is, how does Kubernetes handle applications that need to store state? So this is a great question, because Kubernetes has a feature called stateful sets. And that's really how we handle applications that need state. Now, if you remember from the demo, we saw my pod running, and the identity of the pod was, it was like that hello node, and it had like a bunch of like random, what looked like random characters after that. So that's the identity of the pod itself. Now, that works great for stateless applications. If you have like web servers, for example, right? If you have an Nginx web server and you have 100 of them, and some go down, you just add more. So it's great for that. But stateful applications such as like a database or a messaging type of queue, or these types of applications that need to have identity and discoverability, it's actually very important that you don't have that randomized sort of like looking string. If you have, for example, like MySQL 1, for example, and there's another, I think MySQL question coming up here, but like if you have MySQL 0, 1, 2, 3, and if 2 goes down, you actually want that to come back up again, not as MySQL some random string, but MySQL 2, so that it can get rediscovered by the MySQL master and things like that. So to run a stateful application, you need to use a feature called stateful sets. And stateful sets is really what's going to enable to have that identity of the pod preserved over and over again, so that really these failures act much more like a machine sort of reboots, and they act like killing the machine and firing up a new one. So take a look at stateful sets. It is a bit more complex than running a stateless application, so if you don't need it, I wouldn't say you should needlessly use it, but as Kubernetes supports more and more stateful workloads, such as things like Spark, Kafka, Cassandra, Zookeeper, these types of applications, then you really do need to maintain the state and run these things in a stateful set. Next question is, what's the difference between running Kubernetes on Compute Engine versus Container Engine? So yeah, there are a few differences there. So Container Engine, as I mentioned earlier, is a managed Kubernetes service, so we handle everything for you. So Kubernetes has a master, it has nodes, we manage the master for you. It stays up and running. If you start adding more and more nodes, so we need to increase the machine type that the master is running in, we'll do that for you behind the scenes. We'll upgrade Kubernetes for you. There are features within Container Engine to keep your clusters automatically updated. We'll automatically repair things for you. And in short, in Container Engine, we do all the work to make sure that your Kubernetes cluster stays up and running. With Compute Engine, you're a little bit more on your own. You have your managed instance groups, but you need to set up your own masters. You need to set up your nodes. You need to connect them together through networking. If your Kubernetes master or some of the were to go down, then you would need to go out and fix that, as opposed to us fixing that. So it's a little bit different in terms of the way the applications are running. But with Compute Engine, you do have you have more control over the actual configuration of Kubernetes itself, right? If there's a feature that's in alpha, for example, in Container Engine, we'll usually make that available in an alpha cluster. But if you want to run that in production because that's what you feel like doing, you can do things like that in Compute Engine because you have full control over your Kubernetes instances that are running. So next question is, how should I choose which node image to run? So container optimized OS or Ubuntu? So there are two node images that are available in Container Engine today. Container optimized OS, and we have an Ubuntu image that's available in there. So for container optimized OS, that's the default image, and that's really the image that we recommend that you use. It's the image that's largely supported, supported by internal Google teams. We have a new image that gets updated regularly. It's constantly updated with latest security patches, things like that. So, but it is locked down, so you can't do things like make kernel updates. If you wanted to optimize your kernel and recompile your kernel, things like that are not possible with container optimized OS. So if you're running applications that require kernel module changes, if you want to tweak and modify your kernel for any reason, those are the types of use cases where you would then use Ubuntu. But typically, for most of our customers, they use container optimized OS, and that's really the operating system that we would recommend for your node images. Okay. I think there's another page of questions, maybe, or yeah. Okay, so next question is, if I need to run a service like MySQL that's also offered as a cloud service, for example, Google Cloud SQL, should I run it in the cluster or should I use cloud? So another good question. So so an application like MySQL, you can run in your Kubernetes cluster in the way I mentioned earlier using stateful sets. That's one way that you can build this and run this as a container. And some of the reasons to do so are some of the things that we talked about. Efficient resource utilization. If you already have a Kubernetes cluster and you're running your applications in that cluster, then and you want to leverage that same cluster to run your database, then yeah, you should feel free to do so in Kubernetes as well, in Container Engine or running it in the Kubernetes cluster. Now, for a cloud managed service like Cloud SQL, that has its own set of conveniences and strengths as well. So if running your MySQL in Cloud SQL works for you and you're happy with that and everything works great, and you don't have any problems with that, I actually recommend that you should do that. I mean, it'll work pretty well. So a lot of times I start off with that, but if you want to more efficiently and optimize the existing resources that you have, then go ahead and add that to your Kubernetes cluster. It will take some work to get it up and running with features like stateful sets to get it up and running, but you'll be more efficient in that sense in terms of more efficiently using the resources that you have. So the last question here is around GPU. So it says, do you support GPU workloads? So the answer is yes. This is a pretty cool topic, and it's an exciting topic because a lot of this hasn't necessarily been released that publicly yet, but we are supporting GPUs in Container Engine. We have a few GPUs available right now in alpha. So if this is of interest to you, then feel free to reach out. You can reach out to me. You can reach out to anyone here on the Google Container Engine team or the Google Cloud Platform to tell them you're interested in this. And we can get you set up so that you can start running GPUs in alpha clusters in Container Engine. So now imagine if you have like a machine learning workload, things like image processing, big data processing. If you're a biotech company, you want to run some genomics. Like these are all the different types of jobs that you can run that can take advantage of hardware accelerators like GPUs. So this is a big area of investment for us, and this is a big area of focus. And like I said, we have a few GPUs available right now in alpha that you can take advantage of, but there's a lot more exciting news coming in this area over the next few months. So definitely keep an ear out because we do want to support a lot of these workloads in Kubernetes and Container Engine as well. So yeah, thanks. That's the last set of questions I had. Thank you so much for taking the time with me today, and please hang on for the next set of talks. We have more talks coming up later today. So thank you very much. Bye.